Hello everyone again. Today we're going to be talking about rationalizing denominators. The most important thing you need to know is that when we're working with fractions, the denominator cannot be an irrational number. What that means in layman's terms is there can be no radicals on the bottom. If a numerator is not evenly divisible by the denominator, like some of the problems we were doing before, we have to get rid of that radical on the bottom by doing what we call rationalizing the denominator. To rationalize the denominator means to rewrite the fraction as an equivalent form with a rational number in the denominator. So there's two different kinds of problems you might see. You might see something that has a monomial denominator. So there's only one term on the bottom. So something simple like 8 over the square root of 2. That's a monomial denominator. When you're doing that, you want to multiply the top and bottom by the radical that's in the denominator. So for example, in this here, 8 over square root of 2, you would multiply the top and the bottom by square root of 2 and square root of 2, like that. And then you want to simplify. You always want to simplify. If there happens to be a binomial in the denominator, so there's two terms, so something like 8 over 1 plus the square root of 2. Now you have two terms in the bottom here. You want to multiply the top and bottom by what's called the conjugate. Oops, misspelled that. That's a J. C-O-N-J-U-G-A-T-E. By the conjugate of the bottom. And this is kind of like that difference of two perfect square things. So in this example here, the conjugate of this is the same numbers, so it'll be 1 and square root of 2, but instead of having a plus, now we want to make it a minus, so that's the conjugate. So it'll be 1 minus square root of 2 here. And what that does is it's actually going to cancel some stuff out, as you'll see in just a minute. One note really quick is that the square root of 3 times the square root of 3 is going to be whatever's left underneath that radical. So square root of 3 times square root of 3 is just 3, because that actually ends up to be square root of 9, which as we know is just 3. And the same kind of thing happens over here. If we multiply these two together, we end up with 2 radical 25, or just 2 times 5, which is 10. Okay? Alright, so on to a couple of examples here. You'll notice that 1a and 1b, 2a and 2b are the same. That's because we're going to do two different approaches here. Okay, so looking at this first one, we want to follow those steps that we had a second ago. We have a monomial denominator, so we want to go ahead and multiply this by whatever radical is in the bottom. So in this case, it's radical 8. So we want to multiply by radical 8 on the bottom, radical 8 on the top. That will give us, we can't multiply these together, so we just have 10 square root of 8 over square root of 8 times the square root of 8 is the square root of 64, which as we know becomes 10 square root of 8 over 8. Now we're going to be able to reduce this a little bit, which will give us 5 radical 8 over 4. And then that square root of 8 can be broken down one more step, so that we actually have 5 square root of 4 square root of 2, because 4 times 2 gives us that 8, over 4, which ends up being 5 times 2 radical 2 over 4. And then we can cancel these down a little bit. So our final answer for this problem is going to be 5 square root of 2 over 2. Now, if you had gone a different way and said, well, I know that the square root of 8 can be broken down a little bit first. I know that that can be broken down, we'll have our 10 on the top still, into that 4 and 2, square root of 4, square root of 2. So before you even move on, you could simplify that and start off with 10 over 2 square root of 2. From here, you can simplify a little bit more, so that you actually end up with 5 over the square root of 2. And then you can go ahead and you have that monomial denominator, so multiply by the square root of 2 over the square root of 2. And your final answer, just like we had over there, is actually going to be 5 square root of 2 over, well, radical 2 times radical 2 gives us a radical 4, which is 5 radical 2 over 2. They end up being the same either way. So you can simplify beforehand, or you can simplify afterwards. It doesn't matter. That's actually going to make a big difference down here, because now we're talking about cube roots. So again, we have that monomial denominator, so we want to go ahead and multiply through by the cube root of 9. But the problem is we have a cube root, so we need to have 3 of them. So cube root of 9 and then cube root of 9 again. On the top, multiply by cube root of 9, cube root of 9 again. Now this is going to make some really big numbers, which is why we'll talk about simplifying in just a second. So on the top, we're going to have the cube root of 6 times 9 times 9, which if we use our handy dandy calculator, 6 times 9 times 9 gives us 486 over 4 cube root of 9 times 9 times 9, which is 729. Okay, this will give us the cube root of 486 over, well, we know that the cube root of 729 is 9, so 4 times 9. Now we need to ask ourselves, are there any perfect cubes that go into 486? Well, 486 divided by 8 doesn't work. 486 divided by 27 does work, and that gives us an 18. So this will be the cube root of 27 times the cube root of 18 all over 4 times 9 is 36. Cube root of 27 is 3, so we have 3 cube root of 18 over 36. And if we reduce that one more time, we will end up with just the cube root of 18, because this can cancel here. We'll have a 1, so you could write a 1. And then 36 ends up being a 12, because divided by 3 divided by 3. So 1 cube root of 18 over 12. This next part here, we're actually going to simplify it a little bit first. So we're going to go back to that quotient property that said that you can take the outsides and divide them. So we'll have 1 over 4. And then we're actually going to have one big cube root of 6 over 9. And the reason that's going to help us is because we can reduce this a little bit, right? 6 over 9 actually turns into 2 over 3, right? So we're going to have 1 cube root of 2 over 4 cube root of 3. This is going to make the numbers a little bit more manageable, and we're not going to have to reduce at the end. The denominator we want to multiply just like we did over here with the 9s. We're going to use the 3s this time, though. We want to multiply the top and the bottom by cube root of 3, cube root of 3, and then the same thing on the bottom, cube root of 3, cube root of 3. And that's going to give us on the top 1 cube root. 2 times 3 is 6, times 3 again is 18. And on the bottom, we're going to have 4 times the cube root of 3, the cube root of 3, the cube root of 3, so 3 times 3 is 9, times 3 is 27, so the cube root of 27. which, as we know already, the cube root of 27 is actually 3. So we have the cube root of 18 over 4 times 3, which gives us the cube root of 18 over 12. The exact same thing we ended up with over here. Moving on to number 3. This one does not have a monomial denominator. It actually has two terms in the bottom, so we're going to practice that conjugate thing. So what I want you to do is I want you to put this in parentheses, and we want to multiply the top and the bottom by the conjugate, the opposite sign of this. So it's going to be a 3 and a square root of 5, but in the middle now we're going to have a plus. And you're going to do the same thing on top, 3 plus square root of 5. And now what ends up happening here is actually really kind of neat. We can distribute the top, so we're going to have 6 times 3, which is 18, plus 6 times square root of 5, which is just 6 square root of 5. On the bottom, we're going to have to FOIL these out. 3 times 3 gives us a 9. The outers, 3 times positive square root of 5 is plus 3 square root of 5. The inners, 3 times negative square root of 5 is minus 3 square root of 5. And then the last, negative square root of 5 times positive square root of 5 gives us a negative square root of 25. So the reason that's neat is because when you multiply that conjugate, these inners and outers cancel here. Positive 3 square root of 5, negative 3 square root of 5 cancel. So on the bottom now, we're going to have a 9, and we know that the square root of 25 is going to end up to be just 5. So we'll have 18 plus 6 square root of 5 over 9 minus 5, which ends up to be 18 plus 6 square root of 5 over 4. And we can reduce that just a little bit because you can factor a 2 out of the top here. So we'll have 2 and then 9 plus 3 square root of 5 over 4. You can reduce that down, and your final answer, you should end up with something like 9 plus 3 square root of 5 over 2. This bottom one down here, I'm actually not going to go through. I would like you to try it on your own so that you get a little bit of individual practice here. We will go over it first thing when you come into class tomorrow. So go ahead, you're going to multiply by the conjugate, see if you can work out the whole thing on your own. The top is a little trickier, but I think you can do it. Have a great night.